let me start by talking about what it takes to be a binomial experiment. Okay, so the word binomial includes the prefix bi, which bi means two, like a bicycle has two wheels. So binomial experiments, and I'm going to jump down to the second bullet point, have only two outcomes possible. And we categorize those two outcomes as success and failure. So like when we were talking about yesterday, rolling a single-sided die, what are the outcomes that are possible when I roll the die? Rolling a 1, 2, 3, 4, 5, 6. That's not binomial because there's 6 outcomes. I can change an example, and we'll do this in example 2, where I can make rolling a die a binomial experiment if I look for a specific type of outcome. So like if you look ahead to example 2 on the notes, it says find the probability of rolling a 5 exactly 3 times. So then 5 becomes success and everything else is failure. A 1, a 2, a 3, a 4, a 6, failure. They're not their own individual outcomes anymore. So that's the big thing about binomial experiments. There's only 2 things that can happen. You can have a success, you can have a failure. Other things you need to know in order to be a binomial experiment. It has to be independent trials. So that means that what happens in one trial will not affect or change the probability of what happens in the second trial. We need the same probability for success all the way through. And we're going to know how many trials we run. This could be actually performing an experiment, like rolling a die, or this could be like selecting from a group of people. I'm selecting 5 people. Those are my 5 trials. Okay. And then going along with the fact that it's independent, you have a probability of success, and it will be the same for each trial. That's P. And then the probability of failure will be not having a success, so it will be the complement, 1 minus P. If the probability of success is 70%, then the probability of failure is 30%. Okay. Now, the only other thing that I want to mention going forward is something very interesting that happens in the study of statistics, and that's in mathematics, you have to totally remove the positive and the negative connotation of success and failure. Okay. So I could do a study, and I could look up some statistics that says 20% of juniors fail Algebra 2. Bad. 10% of juniors fail Algebra 2. And I see the statistic, and then I could go out and I could do my own test where I'm going to pick 5 juniors. Okay? And I want to see if they fail Algebra 2 or if they pass Algebra 2. Okay? If I want to know from that group what's the probability that 2 of those students actually ended up failing Algebra 2, what I'm looking for is a failure of Algebra 2. So my success in binomial experiment is finding a student who failed. And that'll sort of go against people's minds a little bit, okay? But mathematically, the success is what you're looking for, what probability you're looking for. So if I'm looking for a student who failed, that becomes my success, and a student who passes is a failure in my experiment. So just remember that if you're ever reading a problem, good things don't have to be successes. Bad things can be successes, and good things can be failures. Okay, so it's more about like what you're actually trying to find the probability of. That becomes your success. What you're not trying to find the probability of becomes your failure. Okay, so that's an interesting thing that happens. Okay. The other thing we want to do is break down this formula for binomial probability. And I would say it's really grouped into like 3 different parts. Okay. The first part you have to do is a combination. Okay, so we've been working with our counting methods. We know how to do the combination in our calculator. And you have to choose very wisely the 2 numbers that you'll use for your combination. What does n represent? The number of trials. Okay, so N is your total trials. That could be how many times you roll the dice, or how many people you pick from a larger group to survey. K is the number of successes that you're looking for. So do I want 2 successes? Do I want 3 successes? Okay, that's all dependent on what I'm looking for. So the number of successes that I want to find. The other part of the formula, there's 2 other parts. I break them up and I would say one part is all about success. So that P to the K is everything that I know about success. It's what my probability of success is raised to the number of successes. The probability of success raised to the number of successes. So that's everything I know about success in my experiment. And then all this stuff at the back that has subtraction, you'll see when I do my examples, I don't really worry too much about doing this in the actual formula. All of this stuff just represents my failure. So the P to the K is my probability of success raised to my number of successes. 1 minus P to the N minus K is formula for the probability of failure raised to the number of failures. And so I think about this more of a combination of my total trials, taken however many successes I want, times my probability of success raised to the number of successes that I want, times the probability of failures raised to the number of failures I must have based on how many successes I wanted. So if you think about it like that, I think that will make plugging into the formula a little bit easier. I'm going to leave the formula on the whiteboard over there so that we can refer back to it and you can look back at the top of your page. But you'll see when I do some of the examples, I'll do some shortcuts for this so that I'm not actually plugging this into a formula. So I don't really need to do the formula for that. I can just think about it. Okay, so let's do example 2. And example 2 is just using the binomial probability formula one time to calculate this single probability. So I want to find the probability of rolling a 5 exactly 3 times out of 10. So I want to think about, can someone grab the door? I don't know who's there. Are you scared? Oh, okay.
Excuse me, sorry to interrupt.
That's all right. Oh, yeah, that's fine. Oh, Damon, I hope you're not in trouble. Find the probability of rolling a 5 exactly 3 times out of 10. So here's the thing I'll say about binomial probabilities. Figure out what success and failure is. What are we going to call a success in this example? What do we want to do? Roll a 5. Okay, so let's call a success rolling a 5. I'm going to write that down. I don't always write this down, but I think it's helpful for our notes so that we know. The success is that I roll a 5. Can you calculate the probability of that? What is the probability that you roll a 5? 1 out of 6. Yes. If success is rolling a 5, what's failure? What's that? Oh, 1 through 4 and 6. What were you going to say, Kylie? Rolling anything but a 5. So I'm going to write that as not rolling a 5. And then we could write what Faith said, roll a 1, a 2, a 3, a 4, or a 6. Those are all failures now. What's the probability of failure? 5, 6, because there's 5 outcomes that we are considering failures. You could also get this by doing 1 minus 1/6, or you could just count up what your failures are, right? 5 out of 6. Okay, how many trials am I performing in this experiment? 10 trials. Okay. These are my total trials right here. So n equals 10. And what's the number of successes I'm looking for? I'm looking for 3 successes. So now that I've identified what P, K, 1 minus P, and N are, I should be able to go to this formula and start plugging in. Okay, so I'm going to do the probability of 3 successes. So rolling the 5 3 times, however you want to write it is totally up to you. Okay, the probability of 3 successes is equal to, and I have to start with that combination piece. Okay, remember, you need to know that your combination is N choose K. Total choose success. So our total trials is 10, our successes is 3. So 10 choose 6. Now, the next part of my formula is all about success. So everything I know about success is the probability of success is 1/6, and I want to have exactly 3 successes. So I'm going to take that 1/6 and raise it to the 3rd. Multiply it by itself 3 times. So that's all my success information. And now the last part of my formula is all my failure information. I want to take the probability of failure and raise it to the number of failures. We decided our probability of failure was 5 6. If we have 3 successes and 10 total trials, how many failures are there? 7, right? 3 of them are successes, the other 7 must be failures to get to 10 total trials. So 5 to the 6th raised to the 7th. This is my probability of failure, 5 6, raised to the number of failures, which is 7. Okay, because I have to have 10 total trials. These 2 exponents should always add up to your n. 3 and 7, add to 10. Now, here's the other thing we want to do. Type this into our calculators and make sure we can all get the correct decimal, 0.155. I highly recommend using a calculator that has what I would call a 2-line display, so you can see the line that you're typing, and then when you hit enter, you can see the answer. And I may tell you to come up and grab one of mine, only because on the next example, we want to make our lives a little bit easier and use one of the features of the calculator. So can you type this in and see if you can get the correct answer? Example 3. We want to, in part A, I'm jumping before I read the problem, draw a histogram of the binomial distribution for your survey. So remember, the histogram is that bar chart. Okay? So we're going to do our histogram. I'm at least going to get it kind of set up. Where yesterday we did like outcomes on the bottom, now we can do the number of successes on the bottom. And then to figure out what numbers we're going to put there, we need to kind of go back up into the problem and reread that. So it says, according to a survey, about 62% of adults have visited a dentist in the past year. You've asked 5 randomly selected adults whether they have visited a dentist in the past year. So what are your possible numbers of successes when you talk to 5 people? How many of them could have visited the dentist? 5, or 4, or 3, or 2, or 1, or 0. So those will be your numbers of successes. 0, 1, 2, 3, 4, 5. If I'm talking to 5 people, I have 0 through 5. If I'm talking to 3 people, I have 0 to 3. Okay. If I'm rolling a die 10 times, I have 0 to 10. Okay. Now, to get the heights of your bars, you need to calculate the probabilities of each of those successes, which means we have to run this binomial probability 6 times. We have to do it for 0, we have to do it for 1, for 2, for 3, for 4, for 5 successes. Okay. So I'm going to set up the 0. The probability of 0 successes or 0 adults out of 5 visiting the dentist in the past year is equal to a combination of, how many total people am I surveying? 5. Chosen 0 at a time, so I'm looking for 0 successes. What is my probability of success? That they visited the dentist. Tells you, what's the probability of success? 0.62. If the probability of success is 0.62, what's the probability of failure? What's the probability they didn't visit the dentist? 0.38. Now, I would argue this is an example where success seems to go along with something good. Like, it's good that you went to the dentist in the past year, okay, but it could have been reversed. Okay, so I'm going to do a probability of success, which is 0.62. I'm going to raise it to 0, because I'm first looking for 0 successes. And then the next part of the formula is all about failures. So 0.38 raised to the, how many failures would I have with 0 successes here? 5. Now I need everybody to type that into their calculators, and then I'll teach you a trick for how to do the later problems to make it a little bit easier. Okay, so everybody type it in right now. I really want to repeat this over again for all the possible outcomes, the different number of successes that I could have. So my next possible success is the probability that one of the adults have visited the dentist in the past year. I'm going to write out this probability, and I won't do this for the other ones. Okay? But all I would be changing is my number of successes. So instead of 5 choose 0, it's now 5 choose 1. And instead of 0.62 raised to the 0, it's 0.62 raised to the first. And then because I now have 1 success, my number of failures will drop, and my number of failures will be 4. So the only 3 numbers that have changed are these 3 that I have written in red. Okay. So your calculator has a very nice feature that will allow you to go back into the thing you just did. So you guys should have the 5 choose 0 on your screens. For most of you on those small calculators, you just have to hit the up button. And as soon as you hit up, you're in what you were doing before, and you can go scroll right on. If you put your cursor right on top of 0, you can just type 1. And then you'll do that, and you'll change those 3 numbers, okay, and get a new probability. You have to hit second enter. And then you can go back through. Anybody else having trouble getting theirs to work? Once you get going. I won't write out the formula each time. Okay, so now I'm going back into my calculator, and I'm going to do 2 successes, which means 3 failures. So I got to change all my 1s to 2s and my 4 to a 3. I've got to do 3 successes and 2 failures. 4 successes and 1 failure. And 5 successes and 0 failures. So go ahead. Go. 2 failures. If there are 2 failures and 5 trials, there should be 3. 2 successes and 5 trials, there should be 3 failures. So if your exponents have to add 5. Let me know if you're not getting those numbers. I change 3 numbers each time. Well, a little time consuming to go back into our calculators. There are some cheats that make it a little bit more reasonable. The last thing that I want to do is go through and create the actual histogram. So remember how yesterday we talked about on the histogram, you should draw bars with higher probabilities, so the bars are higher. Bars with lower probabilities should have lower probabilities. Okay, so I'm just going to kind of look over my different probabilities that I need to graph. The first one is 0.008, or you could round that to like 0.01. That's a very small probability, so I'll draw a very small bar. You guys can draw better small ones on your paper than I can on the smartboard. So I'm going to draw something very small. I'm just going to label 0.008 or 0.001 right there on the top of it. The next probability was 0.065, which is also pretty small. It's a little bit more than the other one. So I'll draw that bar a little bit taller. 0.065. And then my next one is 0.211, which is much bigger than 0.065. Okay. So I'm going to go ahead and draw that one a little bit taller than the other two and call that 0.211. For 3 successes, I'm at 0.344, so still taller. And then 4 successes was 0.281. 0.28 is going to be somewhere between 0.21 and 0.34. So my bar should be drawn accordingly. It should not be taller than my tallest, but it should be taller than the probability for 2. So I'll put it somewhere in the middle of those. So 0.281. And then my last one is 0.092. That one's a little bit taller than the first 2, or a little bit more than the first 2, so I'll just draw something that's a little bit taller, 0.09. So the histogram doesn't have to be something super fancy where you're scaling the whole side. Okay. More so just that you have the bars drawn with varying heights. Now, the histogram will be really helpful to answer follow-up questions. So, what's the most likely outcome in this survey? If I survey 5 adults, what's most likely? How many visited the dentist? Riley, you say? 3, because it has the highest probability. It's the tallest bar. So 3 is most likely. I can also use a histogram, and it will help make better sense out of a question like C, which is, what's the probability that more than 3 people surveyed have visited a dentist in the past year? What's more than 3 in our experiment? 4 and 5. Okay. So I'm looking at these two columns, the 4 column and the 5 column, because those are more than 3. What do you suppose you might do with those probabilities? Add them together. That's all you gotta do. 0.281 plus 0.092. 0.373. For the test on Friday, I will provide you with the binomial probability formula. Okay, so you'll have this piece right here. But you'll need to be able to decide what all of those things are and how to plug in. The best way to make sure that you know how to do that is through the practice. So doing the homework tonight, we'll do review on Wednesday and Thursday in class, but make sure that you're actually figuring out what numbers go into the formula. How do I type them into my calculator? Okay. Make sure that you're typing them into the calculator so you have muscle memory and you remember how to do that.